I will invite our last presenter today, Jari Palari from Taika 3D from Finland. After his first interesting presentation last time, today he will present us a design automatization demonstration for bespoke foot orthotic design. So more specific topic from his field of expertise and knowledge and Jari, thank you once again for joining us and support our project. And please, you're welcome to share your screen and shows us your presentation.
Thank you, Damir, for the invitation to this demonstration and to the previous presentation as well. And so my name is Jari Palari, and I'm from a small company called Taika 3D, and we are based in Espoo in Finland and in a couple of locations in the UK. And our field of business, which is the same as this demonstration, really is the design automation of in the orthotics and prosthetics industry, or O&P. And I think here you can find a lot of similarities with other related industries in the medical field and 3D printing. And I think one of the key issues in kind of really utilizing the potential that 3D printing has in the field and really adding value to the patient and to the companies in the field. You have to really be able to kind of scale the design process up, because if you design something just one at a time manually for certain really kind of complex cases, you probably don't have a choice. But in most cases, you are dealing with very similar shapes with custom geometry, yes, which is difficult to work with, but basically the process that you take in your design is very similar from one patient to another. And that is basically the trying to automate these repetitive kind of steps is what we are kind of all about. And we have been able to kind of successfully deliver kind of automated design systems for a number of businesses around Europe and North America, and and this is kind of what we do and what basically everybody does in this industry, which is basically once you see your patient and you have the information from there, this is your input data. You then do your design, you do something, and then once you've finished, then you move to the manufacturing side, which is kind of, even with additive manufacturing, is quite established, and service providers, and if you have your machines, you know how to use them, and this is kind of how I would put it, easy. This is the easy stuff. So anyway, today I want to talk about this blue box, and I show you a little bit what's in there. So the input data that we've got is typically a 3D scan, an optical 3D scan with a structure sensor or something similar. And in this case, it's a scan of a foot of a patient. And on top of that, we need to know what to do with that data. So we need an order form, and that's usually also the clinician will fill in that form when they are with the patient in clinic, and all of that data gets sent in one packet to our system. So this is the input. And basically what happens then is that we clean that up as much as possible, try and fill some of the holes. That's like in this case, for example, you can, I don't know if you can see my mouse pointer, but you get a bit of sofa in the scan as well. Obviously that's not required to make an orthotic device, so we try and remove all these kind of extra surfaces, and then we can basically start to realign the the scan, so that we know that, okay, is it the left foot or a right foot? Is it kind of this way is forward, this way is up, things like that. So we need to analyze the shape coming in, and then we can start to identify certain anatomical landmarks from that shape. After that, we can use that information to create kind of an outline of the device, and from that outline, then we can create a solid, and then whatever whatever features the clinician has requested for that particular patient, and once those are added and confirmed that yes, and compared against the scan, then you can then export that, and then it goes to manufacturing, and everything follows kind of more conventional processes from there. So to show you exactly what that looks like, I need to show you on this other machine. So if you bear with me for 1 second, I will try and get this started. Okay. You have to stop this and start on the other one. Okay, so I'm going to show you two different things. One is kind of this semi-automatic approach, where you have to put in the order manually, and then I'll show you the fully automatic approach. So this is what you would do when you are just basically at your office and you receive the orders from various customers, various clinicians, and you can basically just start entering the orders in, and this is not that different from a let's say a conventional design system. You basically just point to the input data. So these are 2 scans. They could be from structure scanner or whatever, and then you go into your order form, and here you have these kind of various selections that you can choose for that product, and this is not a generic design tool that you can make like 10 different medical devices, ankle braces, or prosthetic sockets like an Inventor or Blender. Those would be what I would call generic design tools. This is set up for this particular company and for this particular product, and that's the strength and that's the limitation of that system. Anyway, I have some parameters here, and for the sake of the presentation, let's add a metatarsal pad, and then on the other side, let's do first ray cutout and add some reinforcements there, and let's just save that and then submit. And now it's starting to upload the files to the server, and you should see it pop up here very quickly. And then it starts automatically processing that design into the finished product, which we can then validate. And while it's uploading that, I can also start another upload. So this is now processing, and this is also kind of your typical kind of use case, because your clinicians would be out there in different hospitals seeing patients, and they would be sending orders, and they would then pop up on the server like this. And for the sake of the demonstration, we got this little cheat, so we have a batch of orders that we can just throw in the app here, so that I don't need to manually fill in all of these. So you can see that we've got now a total of 6 orders here, and some of these. So this is in my order form. Okay, is it a 3D printed product, or is it something that should be milled? It is obviously processing, but once the first one of these has been designed, then I can already jump into the validation, and the processing continues in parallel for all the others. So we can basically just directly jump into validating our designs, or I can go and let's wait a bit until we have a couple more. Okay, I can do this calcaneus vertical alignment also if I want to. So here we have 3 main landmarks. We do identify others that basically just align the foot on a ground plane, and that helps us with the automation. But also, if you kind of this is a bit of a messy one, but we can basically start kind of correcting the position of this foot, and obviously here the position is quite needs to be corrected quite a lot, and all this extra surface which is connected here doesn't really help that. But once you're kind of satisfied with the alignment or your landmark locations, so these were identified automatically, but you can tweak the alignment by hand. You can just save that, and it just gives you the next one automatically, so you don't have to kind of go to the menu and click too many buttons, and you can just kind of push through those. You don't necessarily need to do this stage. You can basically just go straight into product validation, which gives you the scans, but it also gives you the finished article. So you basically get this shape automatically, and your job now is to then validate that, okay, does it fit, and does it have the features that the clinician specified in the order form. And we basically just because like if you use conventional CAD, you're just kind of pressing buttons that reflect what the sheet, the specification sheet that you got from the clinician. So kind of if they already made those selections in the order form, then why not use those selections here as well? And here's basically just a checklist that, okay, does it look okay? Is everything where it's supposed to be? Are there any surprises? And then you basically just hit validate, and you move to the next one. And this is the only thing that the designer needs to do. And so this is slightly different because this is a full length design, and this is a milled product because it shows you the top surface and the bottom surface. In this case, it's configured to have just a flat bottom surface. So you would just start then milling this out of a solid block of material. And again, validate, and you can just kind of move through the entire order list like this. So if you get 100 jobs a day, no problem. It won't take you that long to go through them. And obviously, if something is wrong, then you can go to modify the landmarks. You can go to the order form, change things there, but usually that's not really necessary. Sometimes the scan can be like really bad, and then you might need to just pick that order out from the queue and contact the clinician that, look, this scan is not good enough, that we need to figure this out. And kind of once you, okay, so I've validated these two, and well, we can just go through the rest as well. You can just kind of see all these various features, and I think in Axel's presentation we saw some really good examples of what can be achieved in terms of the design and kind of these complex and nice looking geometries, and we have also done kind of something similar, maybe not quite as impressive as that. But these are kind of usually functional components in, and you don't really have a lot of space to kind of play with inside a shoe. So these kind of design elements are usually not there, but text, logos, things like that, serial numbers, that's what we usually do. And in this demonstration app, we only have like little text there, but these could be then added at this stage as well, as long as you can define that, okay, here's my pattern, or here is my texture, and here is where I apply that. Is it the whole outer shell? Is it just, like, for example, this heel section, or what is it? As long as you can define it, then we can code it in, and then it can be done automatically. Yeah, that's kind of it, and yeah, and once these are validated, you can see that it's now ready for manufacture, and this isn't hooked up to any production management system or anything like that. So for our demonstration application, you would need to export the files just manually. You can just download these STLs, or G-code files if it's a milled product, but yeah, for custom applications, we can then link this to production queues. So you could, for example, say that, well, okay, I can assign these to milling machine 1 or 2, or I can send these 3D printed jobs. I can send that to the printing bucket, which is kind of their buffer, where the printing guys then get a flag that, okay, there's a new job here. Figure out which job you're going to nest it in, and that's kind of how you can basically just scale up your device production, and you've got kind of all sorts of possibilities with the designs that can be programmed in, and that all just kind of depends on what the customer wants. And this is just kind of like a small set of functions and different features that we can do. But hopefully this demonstration has made sense and is clear. And I think that is it from me. If you have any questions, then please ask, and also after this, please contact me, and we can talk more. So thank you.
Thank you, Jari, once again for a really interesting presentation, and again for your support to our project in both workshop and summer school. And we have already 2 questions. If you can open it, or I can read it in questions and answers area. Mr. Brovac has some questions because he's also an expert in this area. So you can see the questions.
Yes. So what if a rigid foot with inverted Forefoot, how can you automate the design? I think it depends a little bit. If it is a bad case, then you need to kind of you probably need manual tools to adjust it. So if we are looking at Forefoot Views, basically we do have a feature for Forefoot Balancing. So you kind of essentially you keep the heel where it is, and then you move your forefoot, and you can actually manipulate that in multiple directions. So that is one option. If the I think if the landmarks are easy to locate, the automatic system might also be able to pick that up. But as long as you can define the ground plane, and if it's inverted, then obviously the forefoot's probably not going to be, even if your calcaneus is aligned, then the forefoot won't be right. So, but if the system kind of has enough information to find that ground plane even without the forefoot, then it might be able to apply those corrections even without manual intervention. But in that sense, it's fairly similar to a conventional kind of O&P CAD system. So yeah, I hope that answered the question. It can possibly be automated, but in some cases it can be very difficult because anatomy and kind of musculoskeletal anomalies can always be different, and to have an automatic tool that deals with all of the cases, it can be tricky. And then how do you automate right placement of met pad just based on 3 points? So basically the placement is it is based on design rules that are coded into the system. So if we have first metatarsal head, fifth metatarsal head, and we have the center line of the foot, we have a certain logic that is applied every time. That okay, the front edge, the distal edge of the metatarsal pad is at this level. So that, for example, you go from the y-axis of where you have the first metatarsal head, you go back, let's say 20 millimeters or 20 or 40 millimeters or whatever. Then in your x-axis, it could be that you find the center point between the first and the fifth metatarsal, and you go there, and that's your placement of the pad. However, I think the main issue here is that that kind of could be that you need to offload different metatarsal heads, and that pad always goes in the same place. So you need manual adjustment tools to basically put that in the right place. And we don't have those tools in the demo. I would show you otherwise. But basically, you need to then manually adjust it from the default position to the right place, and also the size and the shape of the pad can be adjusted there.
Okay.
Yeah, yeah. If you have more questions, I'm happy to kind of continue the discussion after this as well.
Yeah. Okay.
So yeah, thank you.
Thank you again. Now, if there may be 1 or 2 questions more. If not, first of all, I would like to thank all of the panelists today, or presenters, and my ask to you is please can you turn on your camera so that I can make one print screen so that every one of us are on the screen, please. Thank you, Jose. Thank you, Axel. Okay. Thank you, Gisela. Okay, we have Yari 2 times, so maybe Mika and Luis
Ah,
are not
sorry.
are not with us anymore. But okay, I will make this type of screen. So thank you a lot, and I hope that everyone. Oh, Mika is here. Okay, thank you, Mika. Before I close this today summer school, I would like to thank all of you, the panelists. I would like to all of the attendees. We have maybe small number of attendees, but I should say more questions than last time. But okay, I hope that this is one of the signs that today's lectures were very interested, and I hope that you'll get some future contacts as a result of today presentations. Once again, thank you all, and I would like to share my screen now. Okay, just to, can you see it now? I hope yes, because at the beginning there was a problem with my slides. So I wish all of you and your families and your closest Merry Christmas and Happy New Year. And I hope that the next one will be the best so far. I hope that it will be in all fields, in your professional and of course personal life. Thank you once again for being a part of our project, which will be finished in next 2 months. And as I announced last time, you can expect, I hope, in first half of next year, a publication of one book in Springer Nature, a guide to additive manufacturing, which is one of our outcomes and deliverables from this project. And thank you very much once again to being part of activities. Thank you, and Merry Christmas, Happy New Year to all of you.
Thank you.
Bye.
Thank you.
Bye.
Merry Christmas. Bye-bye.
Bye-bye.
Bye.